proceeding to the next topic called as page replacement algorithm, right? So in this page replacement algorithms, the terminologies that we are normally coming across in this is the page fault, page hit ratio and the page reference tree, right? So before going with the terminologies, let us understand what do you mean by this page replacement algorithm, right? I will be dividing this page replacement into two sections. Everyone know what do you mean by pages? What do you mean by pages over here? A memory is divided, where the physical memory is divided into different sections. This is our main memory, which is divided into different sections of fixed size. Okay, a memory which is going to divide it into different sections. This particular section is called as pages, right? In our main memory, and each and every pages is having a fixed size of the blocks, right? That is called as page. Now, what do you mean by this replacement? When there is a word comes replacement, when there is an arrival of any of the new pages, right? We have certain pages already into our main memory. Let us assume that we have already certain pages in our main memory, and if that particular page is not at all in use, what do? If it is not in use, we simply remove that pages and allow for the next new pages which is there. That is what a replacement of the things. Normally replacing is been coming across only when that particular page which is not in use, we are going to replace it. That is what a page replacement algorithm, right? So for that, let us go with this detailing with the help of these two figures. Everyone can clearly see that what is this particular diagram? This is our main memory and this is our secondary storage, or else we can say it as disk. We can say this disk or else the secondary storage. What for this disk is used? Disk is basically used to store the pages, right? So here in the main memory, I have written some two blocks. What are these two blocks indicating? Those are the pages, right? And here there are the two pages which is there in the disk. Now according to the page replacement algorithm, this P is the page. This P is the page which is stored into the main memory, right? P is the page which is stored into the main memory, which is not at all used for the future purpose. Or else the stored page which is there in the memory, we are not at all using that process or the page. Then what is the use? It is simply wasting that space, right? If it is simply wasting that page, means what do? I simply swap out the process or the page from my main memory into the disk. That process what we say it as swap out process. Okay, unnecessary storage of that pages which is there in the memory, we are going to remove it out and place it back again to the disk and bringing the new page, right? Bringing the new page into the disk and placed into the memory for execution as well as for the storage. This is called as swapping. This process what we say it as page replacement. Is that clear? That's what I have written. If the page P in the main memory, the page P in the main memory, if it is not used, then what do? We simply swap out, means remove that page from main memory to disk. We are going down to this. Again, the new process, if it is removed, means there might be some other new processes also existing, right? There might be another some 2 to 3 process. Let us say P2, P3, right? And this is also been kept. And again next, this is been swapped in for allocation. If that P2 process is also not in use, what do? Simply again swap out that process and allow, when it is swapped out, means this particular section is been free. What do? Again we bring the next new page from the disk into the main memory. This is how the page we are replacing, right? One page is there and if it is not used, we remove that page and bring the next page. This is what we know as page replacement algorithm. Is that clear? Fine. Now let us go with the next topic called as terminologies used in the PRA, that is page replacement algorithm. Now what are these page replacement algorithm terminologies? Page fault, right? What do you mean by this page fault? everyone, by name itself we can say that fault is nothing but the mistakes, okay, mistakes or some error that has occurred, right? What it is defining, if any program try to access a piece of memory, but if it is not existed in the main memory, you got the meaning of it? Means if any page, program is a page that we are representing with the help of P. If any page, if you want to access a piece of this into the main memory and if it is not found, what we say that there is a page fault occurred. For example, here there are 3 pages, right? Into my secondary disk or secondary storage, how many pages we have here? 3 pages. And if I don't find that P3 into my main memory, what do I say? I try to find out the page 3 into my main memory and I did not find that page into my main memory, then we say that the page fault has come. The thing which we are trying to find it, if it is not found, then we say it is page fault, right? Now next is page hit ratio. In numericals, these particular 3 points is required, right? What do you mean by this page hit ratio? If CPU tries to retrieve the needed page from the main memory, it means that in the CPU, there we have a page, right? This is our CPU. We are in need of the page from the main memory and that page is already existing. CPU whatever page is the main memory whatever page is the same page if it is repeating up. Here is also P1, here is also P1. The CPU is also having the same page, main memory is also having the same page. Means is it not a duplicated copy of it? It is existing in both the things. That's why that kind of the pages we say it as hit ratio. Means repetition of the page which is existing between CPU and the main memory. That is called as hit ratio. Is that clear? Now the next and the third important point is page reference string. Can I give the definition of string? What do you mean by string? Is it not called as a string? Right? Any information which is being stored under the double quotation, right? Or the group of the characters which are being enclosed within the double quotes, right? Single quote is called as also the total characters, right? Sequence of characters we say it as strings, fine? If I say simply as a student over here, this is a sequence of characters which are enclosed within this double quote, fine? This is string. Whereas in case of my operating system, I have to define with respect to pages, right? In a general programming language, I will be taking a high level language. But how to define an operating system? I need to take a group of pages. For example, I am taking this. Okay, these are the group of the pages, sequence of the pages which is being allocated. This particular things which is called as page reference string. That let me define it here. The string of memory references is called as reference string. This is string of memory reference. In the main memory, we will be having the n number of the pages over here. There is a sequence, right? There is a sequence of the pages which is called as a reference string and are generated or tracing the given system and recorded the address of each memory reference string is called as page reference. This you will understand once we solve with the numericals. Once we solve with the problems where reference string, I told you just a sequence of characters which are enclosed within double quote is called a string in case of your programming language. If I am speaking with respect to this operating system, pages is going to enclose within that. And that particular information, obviously we are always recording and keeping track of that information, right? We are going to record it and all the recorded information either we are storing it in the main memory or it's in the disk. That particular thing definition is called as page reference string. Fine?